Hi students, here's a solution to 7-23 from the Grobner textbook that was assigned to you. This example or this question deals with sampling means, which is slightly different than chapter 6, which deals with just taking one sample. So this is the situation where you take the average of a bunch of samples. And remember, we use the central limit theorem, which means that mu x bar is equal to mu, and also sigma x bar is equal to sigma over square root n. So what this does is it gives you a modification of sigma, really, because the mean basically stays the same when you take the sample. So it's the mean of the means is the same as the mean of the population, and the standard deviation of the means is the same as the standard deviation of the population divided by the square root of n. So in this case, I know that mu equals 2000. I know that sigma equals 230. Therefore, I know that mu x bar equals 2000. And sigma x bar must equal to, 230 divided by the square root of the sample size, which in this case is 8. Okay, so what we're going to do is we're going to solve it. Hold on a second, let me erase this. So we're going to draw this situation. Right. In this case, it's not mu anymore. It's mu x bar is the mean of the means. It's the sampling means. And that is equal to 2,000, because it's the same as the population. And sigma x bar is equal to 230 over square root 8, not just 230. So we're looking for the probability the sample mean will exceed 2100. So 2100 will be to the right of 2000. So I'll just draw it here. All right. Okay. So in other words, the average, not just x, it's the average of x, right? The average of the samples is greater than that. So I'm looking for the green part here. Exceed means more. I'm going to have to find the standardized score that goes with each of these. So I know that for mu x bar, it's 0, right? For x bar 2100, z will equal to something, right? And to do that, I know that z equals x bar minus mu x bar over sigma over root n, right? So in this case, x bar is 2100 minus 2000 divided by 230 over square root 8. And I'm going to compute that for you. And I find that this is 1.23. Okay. So I know that I'm looking for the probability that z is greater than 1.23. I'm going to scroll down a little bit. The probability that x bar is greater than 2100 is the same as the probability that z is greater than 1.23. Okay, so we can use Excel or the table again. So if we use the table will show me that 1.2 and 3 is there. 3907. So if this z is 1.23, then I know that this is actually 0.3907. But I'm looking for that part, remember. So let's go back. I know that this is 0.3907. I'm looking for the green part, so I need to subtract from 50%. This is equal to 50% minus 0.3907, and that is 0.5 minus 0.3907 is 10.93%, 0.1093 or 10.93%, right? We can also use Excel to do this because, let me redraw it for you. 1.23 is there, right? Excel will give me all of this because that's the nature of the Excel function. It gives you from the left tail all the way up to the z-score you're looking for. And then we have to subtract from 1. So we type equals norm.s.dist, right? Z is 1.23 comma 1 for cumulative, and I see it's 89, right? 89.8906. All of that. But I'm looking for actually the green part. So it has to be equal to 1 minus that, and it's 10.93 as you see. That's the same. All right. This is an example of using the central limit theorem and sampling means. And that's that.